So in this section, we're now moving into 9.3, some more geometry. This geometry involves triangles. So we have congruency of triangles with similarity of triangles, and we have what's called the Pythagorean theorem working with triangles. So again, we mostly in your work, we're mostly going to be working with some applications involving algebra and geometry. So what that means is we're going to probably focus more on similarity and the Pythagorean theorem because there's more algebra involved in these two types of geometry problems. So in talking about congruent triangles, usually we're comparing two triangles. So congruent triangles, most often you're going to be talking about two triangles. So two triangles are said to be congruent if they are exactly the same size and shape, if they are exactly in the same shape and size. So in other words, the two triangles look identical. In this case, what this means is corresponding sides are equal and corresponding angles are equal. So one of the things you can pick up on is, one triangle can be placed on top of the other and they will perfectly overlap. Now keep in mind you're allowed to rotate and spin and flip. So that's where it gets a little tricky is rotating and spinning, but also flipping. Because a lot of times I forget to flip something over because it can make a big difference. So there are some rules for congruent triangles, and we won't have to do a whole lot of this in our math. I'll just kind of mention them. So two triangles are congruent if any one of these situations or conditions is satisfied. So if the corresponding sides are equal, then the triangles are said to be congruent. So that's one way. So if we compare corresponding sides, if the corresponding sides are the same lengths, then the two triangles are said to be congruent, which means they're identical. One triangle should be able to be set right over top of the other, and they should line up perfectly. Also, if you're being given a side, the included angle, and a side, if we know this is true in both triangles, if we know two sides of the included angle are equal in the two triangles, then that means the two triangles themselves have to be congruent. But again, the angle has to be included. It has to be between the two sides. There's also this angle side angle theorem. So if we can compare if two corresponding angles are congruent and the included side is congruent or equal, if you will, then the two triangles themselves are equal. So we have this ASA theorem, if you will. And then there's this angle S. So if we know two angles, corresponding angles are equal, and just another side that's not included, that will be enough to generate equal or congruent triangles. One of the things they talk about here is because this third angle is going to automatically be 180 degrees, so that third angle is going to be also equal, which then the outside uh, becomes the included side because that third angle is there. So if you look at these diagrams, notice that all three sides are congruent. So from that perspective, since side AB is congruent to side XY, notice how they're corresponding, they're in the same position in the triangles, and we have side BC is congruent to, and notice how this is the congruent symbol. It's like an equal sign. Let me do a little bit better job with my congruent symbols. They're kind of a little sloppy there. My eraser just doesn't seem to want to work here. Jumps around on me. So every time I erase, something happens. So I need to be patient there with my eraser. So side AB, so it's an equal sign, and then it's like a little squiggly line there like that. That's a congruent symbol. So side BC, equal sign with the little thing up above it, is congruent, is our congruent symbol. This is going to be a YZ. So YZ. So BC would correspond to YZ. They're the same length. And what does that leave us? Side AC would be congruent to side XC. So if we have corresponding sides equal, what we conclude then is triangle ABC is going to be congruent, oops, equal sign, then this is going to be congruent to triangle. And we have to write these in the same order. Since I went from A to B to C, we need to go in the same order here, X to Y to Z. Those vertices have to be in the same position. Those endpoints have to be in the same position. So notice how AB, XY, BC, YZ, AC, XC, all the sides are equal. So if I give you two triangles that look alike, they are alike, we use this word congruent, which is another word for equals. That means they look the same. They're the same size and same shape. So next thing is similar triangles. So we'll stop here.